Phase diagrams are diagrams that show the relationship between temperature and pressure and the state in which you find a substance, whether it be in a solid, a liquid, or a gas phase or state. We know that, I think it's common knowledge, that temperature impacts the state of matter, but pressure is also involved. And so we'll talk about that in this unit and in the next unit. The triple point is the point at which the temperature and pressure at which you find, you can find all three phases that will coexist at one time, a solid, liquid, and gas. This is an example of a phase diagram. It shows temperature on the x-axis, pressure on the y. And if you look at a substance, this substance at high temperature and low pressure, it's going to be in the gas phase. If you look at it at low temperature and high pressure, it's going to be in the solid phase, and then liquid is somewhere in the middle. All phase diagrams have this kind of Y shape here. And anything along this line right here will be in what's called a solid liquid equilibrium. And so what that means is that, say at this point where the cursor is right now, at that temperature and pressure, you will find this substance in both a solid and liquid phase. Okay, so if you were to decrease the temperature, it would be a solid. If you were to increase it, it would be a liquid. Anything along any of the pressure temperature points along this line will be in equilibrium between a gas and a liquid. And then anything along this line will be in equilibrium between a solid and a gas. So you'll have equal numbers of solid molecules per gas molecules, for example. These lines suggest a phase change. So if a substance goes from a solid to a liquid, it melts. From a liquid to a solid, it freezes. From a liquid to a gas, vaporizes, and just the opposite is condensation. And from a solid to a gas, sublimation, and just the opposite would be deposition. This point is, you can tell that a solid, a liquid, and a gas all meet at this point. That's the triple point. So the triple point for different substances would have different temperatures and pressures. For example, this is the phase diagram of water. It shows that the triple point, the point at which you will find water is a solid, liquid, and a gas, would be 0.01, just above freezing, and 0.006, what's atmospheres of pressure. And we talked about standard pressure last unit being 1 atmosphere. So if we look at the standard pressure at 1 atmosphere, we will find what we know, our common knowledge is that water freezes at 0, and at 1 atm it boils at 100 degrees. So that is, it is definitely pressure dependent, as well as we knew before, temperature dependent. So in your next step will be to do classwork, complete classwork, reading phase diagrams for various substances.